way you guys are going to take notes. So what I add, I'd love you to also add to your notes as well. Alright, so the domain. Have you heard that word before, domain? Yes? Okay, good. The domain. Good morning.
I'm bringing gifts.
You're bringing gifts.
Here we go. Domain. A couple people said they'd heard that word before. Domain is the set of x values. So when you have an equation, they are the x values that you are plugging in. What do you think the range is then? The y value. So we've got x and we've got y. And so one way that I remember it, and have always kind of remembered it, and I'll teach you my tricks along the way, and they might work for you or you may not love them. Up to you whether you want to use them or not. I think about alphabetical order. So the word domain in alphabetical order comes before the word range, right? D comes before R, and X comes before Y. So that's how I remember domain and X go together, and then range and Y go together. If that works for you, awesome. If it doesn't, that's okay too. So domain and range, we're going to look at a set of graphs and we're going to figure out what our domain and range are. Now, do you see how it says topic 1, domain and range? When you get to your homework worksheet, so for now, the way that it's making me the most comfortable is to make your worksheets, or to make your homework worksheets, so I can make the problems what I want them to be. So when you get your worksheet for homework, it's going to match. So when you start doing problems about domain and range, it's going to say topic number 1. So that way you can go back to your notes and you can look and say, oh hey, this is going to match up. So topic 1, topic 1. Okay? Alright, let's take a look at this first one. I'm going to think domain first, and I might even use 2 different colors. When I'm thinking domain, I'm thinking left to right. Remember your x values are along this axis, and they go all the way to the left and all the way to the right. So think about this line for a minute. It's going to continue on forever and ever. If it was living in the room, it would go up through the ceiling, it would go down through the floor, and it would continue forever. If I look left to right, is there any spot where that graph isn't going to touch eventually? I see some people shaking heads, and I agree with you. Okay, so if you've got this graph that's continuing forever and ever, if I scan across it, it's going to touch that, like looking at those x values, it's going to touch everywhere. So when I write my domain, I'm going to write all real numbers. So my domain is going to include every single real number. Now, I'm going to show you how to write it shorthand. I know a lot of you guys like to write stuff shorthand instead of writing it out in words. That's kind of like a generational thing. I'm good with that. Give me a capital letter R. A capital letter R. That stands for real numbers. And then we're just going to put an extra line through it. That means all of them, please. Not just some of them, all the real numbers. So that's my domain. It's going to eventually span out, and when I think left to right, this line's going to eventually hit everything. Because it's not going to stop ever and ever.
Can we be reminded of what real numbers are?
Ooh, yes. Let's talk about those too. So real numbers, I mean, truly the way to think about it is what isn't a real number. Have we taken square roots before?
Yes.
Okay. So if I told you to take the square root of 4, you would tell me it's 2? Yeah. Okay, so square root of 4 is 2, because 2 times 2 would get you back to 4. So if you take the square root of a negative number, that's when we get into this weird world of imaginary numbers, and that's not where we're living. So we're working only in real numbers, so that's why we're going to say real numbers only, please. So we're restricting it to that set. Alright, I'm trying to decide what color I want. I think I'm going to go bright pink. Okay, range. So my range is up and down, like a mountain range. We're looking at the range and where the graph lives up and down. And again, you're kind of scanning through and you're thinking about, okay, well, where does my graph live? So as this graph continues forever and ever, and again, you kind of have to use your imagination a little bit, if I scan over it, is there any spot my pen wouldn't touch? Or is it gonna eventually hit all those values? Yeah, it'll eventually hit all of them because it's gonna keep going and going and going and going. So again, we're gonna write a capital R with a line through it because it's gonna be all real numbers again. So, not all of these will be all real numbers. Some of them are gonna be different things, and we're gonna see that in part B. So part B is gonna have part of it's all real numbers, part of it's not. Okay, I'm gonna keep doing two separate colors. Again, if you wanna do different colors, if you think that might help you, you can come grab any of my supplies up here and use that as well. Alright, domain. Again, domain is left to right. You don't have to write this every time if you don't want to. I'm gonna write it one more time. When I go to find my domain for this one, I often like to be the graph. So you'll see this a lot where I like to get into the graph here. So I am this parabola. I'm going to continue this way and this way. So is there anything that's going to be off limits left to right? Or is it going to continue out and hit everything?
I think, yeah, it will, yeah.
It will, right? So it's going to continue left and right and hit everything. So this is another one that's all real numbers. Capital R, extra line through it. It's going to be pretty much our symbol of the day. Okay, again, our range is up and down.
But it won't go all the way.
Yes, you're seeing it, right? There's a restriction here. So if we look at this graph, and I'm thinking about down here, is there any graph that lives down here? Okay, so there's no graph, no graph, no graph, no graph, no graph. Do you see how I finally touch the graph right here? And then all the way up I have graph. So what we want to think about is, what level is this? So where are we at right here where I actually touch graph? Because there is no graph down here, right? And again, you don't have to write everything that I write. You should be writing the domain and range for sure. You don't have to write every little bit. Write what's important to you and what helps you make sense of it. So for the range, if this is 0, where we're at x, what is this located at? So this is 0, and I'm going boop, boop, to below it. Negative. 2. So here's how I'm going to write it. My y values have to stay greater than or equal to -2. So let's talk about that just a little bit more because there's kind of a lot to unpack there. So in the range, there's nothing down here, and we want to make sure we kind of say that. So my graph starts at -2. How do I know that? Because if I look at this, -1, -2, -2 is the lowest point it exists. And then it's everything that's bigger than that. So we say y is greater than or equal to -2. So that shows me it's -2 or anything bigger. Go ahead.
Actually, never mind.
Never mind,
I
yeah.
see my question coming up.
Question coming up? Okay. Let's look at the next one. Let's look at domain again first. Remember, domain is your x values. This is what we call an absolute value graph. So absolute values are when you have those lines on either side of something and they make everything positive. So this is an absolute value graph. It's shaped like a V and it's headed off in either direction. Is it going to hit all values to the left and to the right?
Yes.
Yes. So again, my domain is going to be all real numbers. And you're going to find that happens a lot, that your domain is all real numbers. Okay, now let's think about range. There's a restriction. Do you see how your graph isn't going to touch all the values up and down?
Yeah.
Okay, so we've got a restriction. So we're going to write our range. And remember, range is in terms of y. So we can write a y, because that's how we're going to discuss it.
Y is less than.
So think about how it's going. Y is going to be bigger because we're going up. What's the lowest point y can be? So this is 0, 1. Do we agree the lowest that y can be is at 1?
Yeah.
And then it can be anything bigger than 1. So we're going to say y is greater than or equal to 1. Again, because that's where this graph starts. It starts at 1 and then it goes up from there. So we're showing that 1 is the lowest, and then we are counting everything above. How are we doing so far, okay? No? You what? Oh, okay, good. Okay, good. You're making me nervous on day 1. Okay. Told you guys I run a little anxious, so I gotta make sure we're understanding. Now, I almost feel like these examples are easier. I know that there are words and there's a table and it looks like, ooh, it's words. It's not. It's actually, I think, a little bit easier. So this is a kind of like a real life example. We've got raffle tickets, we're selling them. The table shows the number of raffle tickets sold in the first 6 hours. So hour 1, I sold 14, hour 2, I sold 18, and so on. It's asking me again for the domain and the range. 99.9% of the time, they're going to give you your X value on top and your Y value on the bottom. Ooh, and I should have made that cake. I regret that decision already.
Oh, do you have whiteout?
I don't, but I'm just going to write over it and we're going to, that's how we're going to live. That's a pink Y. So typically when you have something in time, it's going to be your X values, it's your independent value, it's what you're kind of basing everything off of. And then your Y is dependent. So the number of tickets depends on what time we were looking at. So when we go to write the domain and range, we're going to write it just a little bit different for these. So write out the word domain for me again. And then this, I think, is one of the symbols in math that's the hardest to write. Are you ready? So you're going to do a little loop like this. And then kind of a more pointy like a triangle. And then another little loop. And this is our set notation. So in math, we consider this set notation. We also call it a brace. You may have seen this symbol before on your computer. Like when you go to type stuff, it's on there. It's on the keyboard. So your domain is all your X values. So what's an X value that you see? If you look back at your list of hours, what's an X value that's there? 4. Now I'm going to write mine in order. So I agree with you that 4 is one of them, but I'm going to go in numeric order. So I'm going to put 4 right there. Let's start at the beginning. What's the first X value you see? 1. And then we see 2, and then 3, and then 4, and then 5, and then 6. And do we agree those are all the X values that we see? So we're going to close that off.
Freshmen and sophomores, please report to the PAC for the freshman and sophomore class meeting.
So again, we're going to close off we call it a brace. So we're going to do a loop, kind of a pointy triangle, and another loop. So that is our domain. So again, for your domain, when you have it listed out like that, you're just going to write down everything that's given to you. Now let's do the range. It's going to be the same thing. So the range is all the possible Y values. So again, loop, pointy, loop. Alright, so hour 1, how many tickets did I sell? 14, so that's going to go in my range. Hour 2, 18, hour 3, 26, hour 4, 36, hour 5, 38, and hour 6, 54. And then we're going to close it off just like we did the other one. So a little loop, pointy, and then another loop. Again, they're kind of hard to make. Every time I make those, I always get like, oh, mine looks awful. Yeah, mine too.
One side's always,
yeah,
I
different.
think, a little easier to do, to manage, and the other side is.
It's like yoga, right? Like one side's a little bit different than the other. We're always a little off. Look, I can bring it back to you. To all the things. Okay, so that's topic 1. So when you get to the homework tonight, you're going to have some problems on that topic. Now, I'm going to pause for a minute. I'm going to give you guys. So this page is going to be even a little bit faster because these are like quick little tests that you do. So have you ever gone to a doctor and you need a little test done to see if you have strep throat? And they like swab your throat and they're like, oh, it's positive or negative. That's kind of what these are. This is going to be a quick little test to decide if something is what we call 1-to-1. So So there's a test you can do to decide. So a one-to-one function is if an element in the function's range is paired with one element in the domain. So what that means is that each x value only gets one y value. And the way that we test that, again, I kind of referenced like a little test that you can do, is called the vertical line test. So the vertical line test means that you're going to just draw a bunch of vertical lines through your graph. You can draw them anywhere, it doesn't matter where. How many times do those lines hit my graph at most? So like, look at this one. How many times does this line hit my graph? Once, right here, right? So I've got one spot where it touches right here. How about this line? Once. Okay, so if you come across a line that hits more than once, then it's not one-to-one. And we'll see one of those in a minute. So decide whether this is one-to-one. The answer is yes. So if the lines hit not at all, or only once, then it's one-to-one. If any of the lines, though, hit two or more times, then at that point it's not one-to-one.
So it's C.
So let's look at part B. If you're okay. I love how you're thinking ahead and thinking like, where are we headed here? If I draw some vertical lines through this, do they touch once or fewer? Do any of them touch two times or more? No. So if they only touch once or not at all, then the answer is yes. And so Demias is already looking at part C. What do you notice is going to happen in part C when I draw a vertical line?
Hit twice.
It's going to hit twice. So is it one-to-one? No. So one-to-one again means that for every one x value, you have one y value. But right here, let's look at this one in particular. For this x value at -3, you have a y value here and here. You have two of them. So that's why it's not one-to-one, because you have two y's that go with this one spot that's an x. So that one's pretty simple. So again, it's just a quick test. Alright, last thing. This is the last bit of notes for today. Here we go. We've got continuous versus discrete versus, there should be a third word, and it is discontinuous. So there are three things it can be. Oops, if I could spell it right. Discontinuous. Okay, by the way, do you see this? I put a little C in there? This little sentence, like I need my readers. So it should be D-I-S-C-O-N, so this is D-I-S-C-O-N-T-I-N-U-O-U-S. So you can either be continuous, discrete, or discontinuous.
I'm a bias point out.
You need one out.
I do, and the only reason I'm writing in pen is I feel like when I write in pencil, it just doesn't pop as much.
No, we want the pop.
Yeah. So what is a continuous function? A continuous function is when it's unbroken. So here's your test for this one. So we talked about like a quick test. If you can draw the graph in one swoop without lifting your pencil, then it's continuous. If you have to pick up your pencil in the process of drawing it, then we're going to say that it's discrete or it's discontinuous. And so truly, actually, we're only going to use these two words right now. I think those are the only two our book wants us to use. All right. So the first one. So continuous is going to be one swoop. Discontinuous is going to be when you have dots. So, and you have something that's discrete with dots. So these are our two choices right here. Continuous one swoop, discrete not one swoop. Okay, here's my first one. It's a vertical line. It's this line right here. Can you draw that without picking up your pencil?
Yes.
Yeah. So I'm going to write continuous. I'm going to spell it correctly, probably.
Maybe.
Maybe.
We'll
This is
see.
the most I would like to commit to.
That's your goal.
Yeah, spelling's never not my best. Okay, this one. Can I draw this graph without picking up my pencil?
Yes.
Yeah, I was gonna say I would have to do a dot, right? And then I'd have to pick up and do another dot, pick up, do another dot. So
He
we
was
call
thinking, could you like
Brought it through a
start
C.
at one
It's
dot
gonna go
and
backwards,
Oh.
bro.
connect it continuously?
if they were connected, then yes. But how they're not connected, like you just have the dots. We can't, yeah, so we call this discrete. So this one is going to be discrete. And sometimes our word for that is also discontinuous. So discrete and discontinuous are kind of two words that mean the same, we call those synonyms. What about this last one? Could you draw it with one swoop? No. So we are going to call it discrete. So if you go to your homework, you've got topic 2 and you've got topic 3, and I'm going to have you go through. So topic 2 was you telling me yes or no. Is it one-to-one? Topic 3 was continuous or discrete. These are the only 2 words you're going to use. Again, that extra word, that discontinuous word that I use, is the same as discrete. Those mean the same thing. So if you wrote discrete or you wrote discontinuous, they mean the same. Okay, so go ahead and try those. I'm going to come around and I'm going to check in notes and classwork. And so you can get all your points for today.